All right, so we're going to find key features today looking at graphs of lines. Okay, we did a little bit of this. Y'all, my turn. We did a little bit of this on Friday with our set builder notation, looking at domain and ranges of certain graphs. Okay, so here we have a new graph. This is a line segment, and the line segment represents a function. Segments, do they go on forever? Caleb, what do you think? Do line segments go on forever? No, they have endpoints, right, Jason? They have ending points. So because of that, we have a restricted domain and a restricted range. Okay, with our domain, we go look at the lowest and the highest x values. Our x's are this axis, right? Those are the positives, and here's our negatives. What is the lowest x value on this line segment? Where does this cross? Looks like the lowest it goes is -3. And then it stops over here on the right to what x value? 5. So the domain of this is going to be in between the x values of -3 and 5. Put your phones away. Next time I'm just going to take them from you and I will keep them. So I'm giving you the chance to put them away. Thank you. Now we're going to use our y values to figure out my range, okay? So with y values, we want to go from the lowest to the highest y value. So how low do my y's go versus how high do my y's go? These are my low ones. Here's my high ones. So looking at this line, this is the lowest side. And what y value is this? About -2.3. And then at the top, what is this y value? 3. So our range goes as low as -2.3 and as high as +3 for my y values. Some other key features we're going to look for. It's a line, so we got no slope, right? Slope is how we move, which is why in our y equals mx plus b, it's our m value, how we move. So let's go from this point to this point. How did I move? What happened? Yeah, there we go. We went down 2 and we went over 3. So how do I write that as a slope?
Y equals 2 over 3x.
Just the slope part. So you're doing the whole equation. I just want the piece that's the slope. How do I show down 2 and over 3? There you go. So it's -2 over 3. Whoop. All right, good. All right, next key feature, we're going to look at how the graph is moving. Okay, so as I move from left to right, as the x values increase, so as we move over to that positive x, what are the y's doing? Are they going up or are they going down? They are going down, so how do I say that in math? Negative, kind of look at the wording it's using. As the x values increase, the y values are decreasing. Good, yeah. So as we move over to the right, my y values are falling down. Okay. So we looked at domain, we looked at range, we looked at my slope, we looked at how they are moving or changing as I move from left to right, and now we're going to look at my intercepts. Okay, the coordinates of the point where the line crosses the y-axis is what? What are the coordinate points? Where does it cross the y-axis? 0, 1. Good. Which one of those is the y value? The 1. Okay, coordinate points are written as x, y. Helps to actually put the 1 right there. Here we go. All right, my next one wants to know the x-axis. Okay, the coordinates of the point where the line crosses the x-axis are what? Mm-hmm. 1.5 and 0. Which one of those is the x value? The 1.5. Okay. The intercept, that's what should go here, is the value of a variable when all other variables in the equation equals 0. Okay, so on a graph, the intercept is the value where a function crosses an axis. So that's what we just did. So what is the value of my x-intercept? It's just the 1.5. Good. What is the value of my y-intercept? Just the 1. So yeah, so where is it actually crossing the x? Where is it actually crossing the y is showing our values. Questions for me? That was our first example. We're going to do these key features again for the line underneath it. All right. Here we go. A line that represents a function is shown on the coordinate plane. The line is similar, I can't read, is similar to the line segment represented in the previous problem, except it does not have endpoints. So what is technically on the end here? We got little arrows. Yeah, nothing. It's not going to stop. It's going to keep on going forever. Who remembers how to say forever? There we go. Something with infinities. Good. My domain, was it my x's or my y's? My x's. So how low can I go on my x? How do I say infinite? Which one, positive or negative? Negative. So we can go as low as negative infinity, right? And we can go as high as what on the other side? Positive infinity. Good. So my graph does stop at 10, but because there's arrows, the line is not stopping at 10. Those arrows are not having endpoints, shows that it's going to keep on going beyond, on. Okay, how about my range? So it's going to be the same thing, right? We're also going down forever and up forever. So we're going to go down to negative infinity, all the way up to positive infinity. Notice my variable changes to a y because we're talking about range now. All right. As our x values increase, what is my y doing? It is decreasing. So this is going to, we read a graph from left to right. So if I was walking across, right? If Olivia was walking across this line, there she is, okay? Would she be going down or going up? She would be falling down. So we are decreasing. All right, it's a line, so you know it's going to have a slope. What's our slope? Or you want to go from here to here? Negative what? We went down how many? We went down 2, and we went over how many? So how do I put that as a slope? Negative 2 over 3. Good. Negative 2/3.